Okay, hello everyone. Welcome to the meeting of the 6LO working group. My name is Carlos Gomez, the other chair is Shweta Bandari, and today we have the first 6LO meeting with our new responsible AD, Eric Klein. So welcome, Eric. And we would also like to take the opportunity to thank the previous responsible AD, Suresh Krishnan, for his help over many years. And for the meeting today, we have minute takers and JavaScribe, Dominique and Rahul. Thanks for helping. And on the slide, you can also find a number of pointers to useful resources, such as the online agenda, the Java room, the Meet Echo, which many of you are using anyway, and the CodeMD. So recall that in this meeting, CodeMD is the tool that we are using for the process of collaborative note-taking. So feel free to join CodeMD and contribute to taking minutes. Next, please. So this is the Notewell. Probably you have read it before. Anyway, recall that it contains a number of pointers to documents that specify IETF policies on a number of important topics. So please make sure that you have read it. Next, please. And this is the agenda for today. So the first presentation is the usual chair's introduction, which is currently in progress. The second presentation is on the status of the IPv6 over PLC draft, which will be given by Remy. After that, we'll have a presentation on the update of the 6LO applicability and use cases draft by Yangun. And then we'll have a presentation of an updated version of a draft entitled Design Considerations for Low Power Internet Protocols. So perhaps some of you may remember that a couple of years ago, there was an initial presentation of this draft in 6LO, and now there has been an update. So today we have a presentation on that. And the last presentation will be given by me as a working group participant on a short new draft entitled 6LO PAN dispatch type for SHIC. So the total time that we have for the session is 50 minutes. And as you can see, we have a quite packed agenda, considering the short total time. Anyway, is there any comment on the agenda? Okay, there appear to be no comments. So we consider the agenda to be approved, and then let's proceed to the next slide.
Carlos, if I may, I was just in the queue there to speak, but your audio is very, very choppy, so we're losing a lot of the every other word. If it help if you stop your video.
Yes.
Yeah. Thanks.
Okay, I hope it's better now. Okay, so then now let's proceed to the report of the working group document status. So we have currently 5 documents in the RC editor queue. By the way, the format is a little bit broken on the screen. Anyway, the first draft in the RC editor queue is the packet delivery deadline time draft. Here there's an important point, which is that perhaps some of you may remember the authors realized there was some issue with how modular arithmetic was being used in the draft. So they proposed a number of updates, and those proposed updates were shared on the mailing list, and there was no objection from the working group on those. However, the updates are not yet in the draft, in the last revision, which is 05. So we have a question for our AD, Eric, which is that we understand that perhaps you have an action point on this to make it sure that the updates will make it to the document before is published. So do we have it right?
The edits did not make it into the editor queue.
Yeah, so the document as it is doesn't still contain the latest updates. So will you make sure that those will be incorporated into the draft before publication?
Yes, I'll follow up.
Okay, thank you. Okay, so then the next 4 documents, which are also in the RC editor queue, are the address protected neighbor discovery, forwarding 6LO band fragments, fragment recovery, and IPv6 backbone router. So these documents, the last 4 and the previous one, correspond or belong to the cluster 310. So perhaps it will not be surprising to see the publication of all of them almost simultaneously. Then the next document is IPv6 over NFC. So you may recall that this document was evaluated by the ISG. Then there were some discussed ballots. The authors updated the draft, and in the role of as the shepherd, I made a review of the draft considering some of the comments from the ISG. So then, well, there was some extensive review here. There were perhaps some issues about the tone of the document, some editorial improvements required, also a couple of technical points. So then the authors updated the draft version. The last version is -16. And well, as the shepherd, my next action will be to check again the document after the update. And well, I don't know, perhaps Eric, our AD, if you would have any suggestion about how to proceed after that.
I was supposed to read and review this, I think, but I got sideswiped by an appeal in another working group that actually ended up consuming 8 weeks. So I should. I think this is on me to get back to do AD follow up and get back to you. Sorry about that.
Okay, well, thank you. And okay, going to the next document, which is IPv6 mesh over BLE links. Publication has been requested. And then the next document is IPv6 over PLC. There was a working group last call on this document, which was completed. The document was updated twice during the working group last call. And today we have a presentation on the current status of the document. And the next one, which is perhaps not visible on the screen, is the one about the 6LO use cases, which has been updated as well after a couple of reviews on the mailing list. And we also have a presentation on that today. So if you can proceed to the next slide, please. Or, well, yeah, it seems like this is the, yeah, okay, this is the last slide. So just some quick report, some recent news on some recent interest from the Bluetooth on IPv6 over Bluetooth Low Energy. As you know, 6LO has been working in this area. 6LO produced RFC 7668, which specifies IPv6 over star topology BLE networks. And also we have been working on the BLE mesh extension, which is extending the previous RFC to mesh topology networks. So it seems like perhaps the Bluetooth SIG is considering a different technical approach, and perhaps that might lead to some new work in 6LO. However, that still remains to be seen. So I guess that we will learn a bit more about that in the next upcoming months. So is there any question, any comment? Okay, so let's see. Yeah, there is a participant in the queue. Subir Das. I'm not hearing.
Sorry, it was a mistake.
Yeah, now I'm hearing you. A mistake, okay. Okay, so then if there are no comments, I guess we can proceed to the next presentation by Remy on the status of IPv6 over PLC.
Me? Hello? Can you hear me? Carlos?
Yes, we hear you correctly.
Okay. Next slide, please. Okay, so the last call of this draft was initiated on April the 20th. Since then, we've received comments from Ijo and Michael. So many thanks to Ijo and Michael. And actually, Ijo has raised an editorial comment. Basically, it is about the reference for IEEE 1901.1. We've updated it to the correct link. And the next page, next slide, please. So Michael has given us a list of comments, including 8 editorial comments and 4 technical comments. We've done related modifications. Today, we will only go through the 4 technical comments. The first comment was to clarify where the short addresses of the PLC device comes from. Actually, the short address can be assigned by the PAN coordinator as per the IEEE PLC standards and the ITU PLC standards, or it can be assigned by the GRC in the COJAP methods, and there is a draft on the COJAP in the 6TCH working group. So next page, please. The second comment was to reference RFC 8064 to enhance the privacy. When generating the interface ID in the previous version, our solution was to limit the usage of the interface ID derived from the MAC address only in the link local address. And the ID derived from short address can be used to generate IPv6 address to communicate with the public network. And thus, the MAC address of a PLC device is not exposed to the public network. And Michael suggested to include another solution as per RFC 8064 to generate a stable IPv6 address using OPAC ID, which is basically a hash method to generate the OPAC interface ID so that the privacy of the device is protected. And next page, please. Next page, please. The third comment is about to include the prefix information option in the router advertisement or not. When the PLC network is using L3 routing, it was a must not in the previous version. However, there is the must not was because that we want to avoid the conflict between the prefix given in the DIO message and the prefix given in the router advertisement. However, there is a special case. In the draft, row unaware leaves, the leaf devices can run without the repo at all. So in this case, the prefix has to be encapsulated in the router advertisement instead of the DIO message. So in this case, the prefix, the PIO, should be encapsulated in the router advertisement message. And next page, please. The last comment is mainly about the authentication during the onboarding process. Michael and I have exchanged several mails talking about this topic. The original test didn't give enough details. So actually, when doing the mutual authentication between the PLC device and the network, it tends to join in. We can use some credentials, like some pre-installed certificates or pre-shared keys, or some additive ID with the help of the MESA service, which can be accessed from public network. And if there is no pre-configured credential at all, the EAP node method can be used, but it requires that the operator has physical access to the device. Well, next page, please. So the next step, I think we can move forward to process this draft further. So any comments on the previous modifications?
Okay, so are there any questions, any comments? Well, so by the way, I hope my audio quality is at least acceptable. So the next step will be to get the Shepherd write-up. I will work on it, plan to work on it shortly. So authors, please be ready also to reply to an email asking about whether you're aware of IPR on the document. So thank you.
Okay, thank you, Carlos.
So now we may proceed to the third presentation, the 6LO applicability and use cases draft by Yonggun.
This is Yonggun Hong. In Korea, this is night, so I say good night, good evening. So this document is the 6LO applicability and use case. Please, next page, please. Yeah, this is the 19th version. So as you can see, the working group document was done in 2016. And in the last year, the 8th version, 8th revision was made. But after that, there are a long time. So in this year, July, we published the 9th revision. Please, next page. So in this 6LO use case document, we considered 6 link layer technology, G-Wave, BLE, DECT BLE, MSTP, NFC, PLC. So I got a comment that not only this technology, but also other technology, for example, WLAN or other technology, but to make narrow down scope of this document, so we consider only these 6 link layer technologies. Please, next page. So it is the comparison across the 6LO link layer technology, G-Wave, BLE, DECT BLE, MSTP, NFC, PLC. So as you can see, the uses of each technology is very diverse, and due to the diverse capabilities, each the requirement is also very diverse. Please next page. Okay, this is the comment and email discussion. So I say to Dominic, he reviewed and gave many comments for this draft, and his comment was very helpful to improve. So I tried to resolve his comment, and then I got a comment from Laurent. His comment was related to Pear's technology, and after published the 19th version, I also got a comment from Living. Yes. Next page, please. Yeah, this is the update after the last IETF meeting. The comment from Dominic. The first comment was that in this draft we used the may and should. So he recommends to refer to RFC 2119. So I think that this draft describes the use case and applicability of 6LO. So we had better to avoid the uses of may and should. So I tried to remove the may and should expression in section 1 and section 5. And Dominic raised comment that in section 1, unbalance between sentence and normal group. So as you can see, I make a balance, harmonize using the all sentence expression. Next page, please. And Dominic also raised the ambiguous expression of PLC. PLC is wired technologies among 6LO link-layer technologies. So PLC has different capabilities compared to wireless technology. So I understand that in the previous expression has some ambiguity. So to remove this ambiguity, I modified the sentence. So I want to read the modification sentence. PLC is data transmission technique that utilize power conductor as medium. Unlike other dedicated communication infrastructure, power conductors are widely available indoors and outdoors. Moreover, wire technologies cause less interference to the radio medium than wireless technologies and are more reliable than their wireless counterpart. PLC is the data transmission technique that utilizes power conducts as medium. So I believe that the modified sentence is has no ambiguity expression of PLC. And Dominic also raised that in the previous draft, there is the expression of possible candidate of the 6LO link-layer technologies. So in the previous version of this draft, we consider the LTC-MTC technology as a 6LO link-layer technology. But after the revision, we decided to remove the LTC-MTC. So thanks to Dominic, so we delete the expression of the possible candidate of the 6LO link-layer technology. Next page, please. So Dominic also raised that the table of comparison between 6LO link-layer technologies, it looks like a mixture of technologies and application. So for example, the text ULE, if text ULE is used for smart metering, but text ULE also can be used to other application, for example, home automation. So in this case, their requirement and the characteristic is a little different. So yes, I agree, but in some point we have a difficult to capture common characteristic of each technologies for different application in limited space. So as you can see, in the first row, we describe the uses of each technologies. So I want to keep the current text, but if you gave more comment, then I'll consider to update this part. And Dominic raised that what is the difference between section 4 and section 6. So in section 6, it provides the 6-row use case example of the each 6-row linked technology. But as you know, these use case examples, some use case example have the real deployment, but in other, the use case examples are not. So in the section 4, we try to provide the real 6-row deployment scenario. And so that is the disrepairsy and netricity. So I think that there is some differences between section 6 and section 4. Next page, please. And yeah, this is the last comment. Dominic says that this is the use case description. So any normal references except the RFC 2191 can move to informative references. So I look over the RFC 7322. So in document, the normative references are essential to implementing or understanding the contents of the RFC, and informative references provide additional information. So if I follow the RFC 7322, except RFC 2119, other references had better to move to informative references. So I modified the change of the references in the normative references and informative references. Next page, please. Yeah, so this is the last phase. So I try to reserve to comment from after the meeting. So I want to ask working group last call once more. So in the next meeting, we will update the draft to the remaining comment. For example, the comment from the living. So that's all. Thank you. Please go to next page. Yes, so thank you for your hearing. So any question and comment, welcome.
Thanks, Young. Since Carlos is the co-author of this draft, and we have gone through one round of a group last call last time, and I see we have addressed all the comments that has been received so far. We can do a shorter second work group last call before progressing the draft, unless there is any objection from the work group. There was also a discussion early on to see if this can be a living document and we could maintain a wiki or something else, but looks like we have received more comments from Dominic and others, and maybe we could ask for a second work group last call. Would that work, Carlos, Eric?
folks read the latest version?
So as an author, perhaps I may say that the previous working group last call ended without feedback. So after that, there was some effort to try to get reviews from the different participants. So there have been a number of updates in the document after the first working group last call, which ended without feedback. So I guess that now it may be a different moment to ask again, to see at least if there is some more explicit support.
And see how it goes on the list.
Okay, so Shweta, unless there's any other comments on this, I guess that next we can move to the presentation by Hudson on design considerations for low power internet protocols.
Hi, thanks. So one disclaimer, I didn't realize that my slides would be navigated for me. So this presentation does have some transitions on some of the slides. But so you just may have to click through a few times on certain slides, just letting you know. Anyway, yeah, I'm Hudson, and I'm presenting an update to an internet draft that I actually originally submitted a couple years ago now, called Design Considerations for Low Power Internet Protocols. And I wanted to briefly review that for anyone here today who maybe wasn't there or hasn't read the original or the updated version, and then talk about some of the updates from the latest version. Next slide, please. So this slide actually has 4 bullets on it. And so basically the outline is that from this work, we had finding number 1 was that 6LoWPAN implementations do not completely interoperate. Finding 2 was that we noticed that this was actually in large part because of code size issues. Finding 3 was that we believe that traditional protocol design principles lead to bloated code in some instances. And then sort of the contribution of this work is 3 low power protocol design principles that we think can solve this. Next slide, please. And this has 3 bullets. So, and the main thing that we have actually added to the updated version of the draft is an evaluation of the principles. And to go about this evaluation, we first modified 6LoWPAN based on our principles, implemented this modified version of 6LoWPAN in an embedded operating system, specifically Kentucky-NG. And then finally, we compared our modified and unmodified versions of 6LoWPAN on a number of compile time and runtime metrics to sort of evaluate how we think that applying the principles resulted in some improvements. Next slide, please. So the initial thing, which I have discussed previously, is that first we conducted an interoperability test between 6 open source 6LoWPAN implementations, specifically those in Kentucky, TinyOS, ARM Embed, Kentucky-NG, OpenThread, and Riot. Next slide, please. And this has, I think, 4 bullets, sorry. And what we found was that each implementation could communicate with the broader internet, but we found that in many cases, they unfortunately couldn't talk to each other. So this is a Wireshark screenshot of an embed device sending a Kentucky device a 6LoWPAN packet that contains an IPv6 extension header. And although the Contiki device sends an acknowledgement at the link layer, it silently drops the packet at the network layer. Next slide, please. And what we actually found is that we could find examples like that previous one between every possible pairing of 6LoWPAN stacks. So what we specifically found was that for each pairing of stacks, we could generate packets that were valid according to the 6LoWPAN standards, but dropped by a different receiving stack. Next slide. So we decided to dig into this some more. This table breaks out all of the features defined in the 6LoWPAN spec, or at least in 4944, 6282, and 6775. And what we found was that feature support was mismatched between all of the stacks, leading to opportunities for failures. So there's sort of lots of examples here. Like you'll see TinyOS supports UDP checksum elision, but if TinyOS is configured to use this feature and sends a packet to a Contiki device, Contiki will drop it because it does not support checksum elision. Similarly, Embed supports IPv6 extension headers, but Riot does not. So a communication including the destination options header, for example, would lead to a dropped packet. And there are a bunch more examples. You probably have to just click forward a few times. I had done a bunch of stuff with circles, but it's probably easier for me to just lay them out like that. I think I lost my screen.
Yeah, same here. It seems like I see like Shweta is offline for a while, so I'll try to share from my home screen.
Would it be easier if I just shared the slides from my screen?
Well, perhaps if there are those transitions, yeah, let's proceed with that.
Sure, thanks. So I'm in the queue, I think. Okay, so yeah, so this is the slide I just finished. Anyway, in terms of looking at why, what we actually found was that this is in large part due to code size concerns by the implementers of each of these stacks. So we found lots of examples looking at the code in each where developers would exclude certain features in order to save on code size or occasionally RAM requirements. And we also often found additional if-defs scattered throughout the code that would allow for exclusion of additional 6LoWPAN features, such as excluding fragmentation or excluding portions of the compression algorithms, etc. And we then wanted to connect that to the flash size that's available on IoT platforms today. So this is a listing of several 15.4 supporting IoT platforms available in the last 8 years. And we find that it spans a reasonably broad range from as low as 64 kilobytes on a really low cost device like the EMB WMB to as much as 512 kilobytes on a sort of more resourceful, perhaps more expensive device like the NRF52840. And while in research, code size is rarely an issue, in real world deployments it often is, and these concerns often trickle down to the embedded operating systems that people use. So we then wanted to compare sort of that previous table with the size that's required by 6LoWPAN stacks today. So what we found looking at the 6LoWPAN code size of each of the stacks that we implemented is that they actually span a pretty broad range, with some of the more complete stacks like Embed and Thread requiring as much as 26 kilobytes. Notably, these numbers all represent strict lower bounds because it can be difficult to precisely attribute code size to 6LoWPAN due to inlining and other factors, and we only included and this analysis code that we were able to precisely attribute to 6LoWPAN in each of these stacks. And so sort of one of the higher level findings was that traditional protocol design principles like Postel's law, which states be liberal in what you accept and conservative in what you send, require receivers to support all non-optional complexity in a protocol. And so it's very difficult for implementations attempting to be very lightweight to shed some of this complexity without compromising interoperability. And that led us to these 3 low power protocol design principles, which were all part of the original draft. So principle 1 is capability spectrum, and basically says that low power protocols, we believe, should support both ultra low energy devices as well as devices with very limited code space. And rather than all devices paying the code size costs of complex energy optimizations, protocols should support a linear spectrum of device capabilities. Principle 2 is capability discovery, and says that there should be a way for devices to determine what capability level to communicate with, given that a spectrum exists. And then protocol 3 is that protocols should specify explicit and reasonable bounds on recursive or variable features so that implementations can safely bound RAM use without potentially compromising interoperability. And finally, we wanted to evaluate the principles specifically to answer these 3 questions. So 1, can capability levels provide a good range of implementation complexity? 2, what is the overhead of capability discovery? And 3, is a linear capability spectrum really better than some form of arbitrary feature selection in which nodes can communicate any features that they want to use out of the entire set? And to do so, we applied these principles to 6LoWPAN. By breaking down individual features of 6LoWPAN into 6 capability levels, where lower levels prioritize features with high energy savings relative to the amount of code size that they require. And so, like, for example, here, like level 0 is just the most basic thing possible for using 6LoWPAN. You have fragmentation and you have uncompressed IPv6 and you have the ability to send ICMP errors. And then going up to a higher level, which unfortunately these don't all fit on the slide because I removed transitions just before this. But higher levels like 5 include more complex things like compression of IPv6 extension headers. Principle 2 is capability discovery. And for that, in our implementation, we used a new neighbor discovery option in router solicitations and neighbor advertisements and a new ICMPv6 message type, 6LoWPAN class unsupported. And then finally, principle 3 is provide reasonable bounds. There's details in the draft, but I'm not going to go into it here because of time concerns. So we implemented all of these changes in Kentucky and G's 6LoWPAN stack, required changing about 500 lines of code. And what we found was that capability levels could provide a good range of implementation complexity. The spectrum spans a nearly 100% increase in code size from level 0 to level 5. We chose Kentucky and G because it was the smallest stack out of all of those that we analyzed. So any savings would be sort of most pronounced here. The overhead of capability discovery, which is the ability for nodes to communicate their capability levels to each other, we found was actually quite small, costing less than 5% of the total 6LoWPAN size, while the maximum size reduction from choosing a lower capability level was something like 10x the cost of discovery. So that led us to the conclusion that capability discovery represents an acceptably low overhead. And then finally, we found that a linear capability spectrum is significantly better than an approach which uses arbitrary feature selection. And the primary reason for this is that arbitrary feature selection has significant runtime costs because low capability nodes cannot compress ICMP responses to higher capability nodes that send them messages that they can't decode. And the reason for this is that low capability nodes do not have a guarantee that the node that they are receiving something from actually supports all of the features which they might want to use in compressing a response. And so arbitrary feature selection actually forces that all ICMP errors be sent completely uncompressed, which is a significant cost. So yeah, in conclusion, we found low power interoperability is hard, which I'm sure is not necessarily surprising to many of you because device deployments have to make trade-offs specific to their requirements. We believe that low power protocols should support different points in the spectrum of trade-offs between code size and energy use, and we present 3 principles that we think can help achieve this. While we did apply these principles to 6LoWPAN, I'm not actually directly recommending these changes to the 6LoWPAN protocol, but just thought that this could be some interesting information for all of you and that you might have some interesting responses. I sent out the updated version of the draft on the 6LO mailing list. So any feedback that you guys have, I would really appreciate. Thanks.
Okay, thank you, Hudson. So as a working group participant, I think that this work is really interesting with lots of very useful and interesting details. And as a chair, I think that there are some protocol actions that you are proposing. So if you aim to develop those further, you may want to consider actually 6LO as the home for such work. And then also please take into account to include the term 6LO in the draft name. So it would be something like draft AER's 6LO.
Okay, yeah, sure thing. So if I want to sort of continue this draft with the 6LO group, then I should add 6LO in the name so that it'll be automatically tracked by the data tracker, is what you're saying?
Yeah, that's it.
Great, thanks.
Okay, so there are no, yeah, Eric is in the queue. Yeah, Eric.
Hudson, I apologize, I haven't read the draft, but you presented some implications for code size, and you also make a claim here on the final slide about energy use. Did you actually, are there comparisons about the energy use about this protocol change, the ND option and the change to DRA?
So in terms of comparisons of energy use, I didn't take any precise energy measurements on any board, but I did look at the size of the packets that are sent at runtime and use that as sort of a proxy for energy use. Unsurprisingly, sending less compressed packets has, significant impact on the total size of all packets sent, but the actual energy overhead of supporting neighbor discovery is relatively low because you only actually have to communicate these additional capability discovery messages as part of the normal neighbor discovery bootstrapping process. So the total bytes added in the common case for high capability devices is still small.
And there are no additional packets required to be sent, or is the generation of ICMP errors?
So the generation of ICMP errors are additional packets where currently nodes would simply silently drop the packets. My argument would generally be that getting errors instead of silent drops is generally desirable in these networks.
It probably produces better behavior rather than relying on back off or something. Yeah.
Yeah.
Thank you.
Thanks.
Okay, so I guess there are no other comments. Perhaps we can continue discussing on the mailing list. And in, say, 1 minute, I may try to give quickly the presentation. I am not yet seeing the screen. Okay, yeah, now I can see Shweta's screen. So yeah, just in, say, a couple of minutes, and anything that happens after 1350 UTC is not official, it's outside of the meeting. So as a working group participant, this is just a short version, short new draft for some proposal. The idea is we've been using RFC 6282 as the basis for header compression in 6LoWPAN or 6LO. However, there has been the recent publication of RFC 8724, which is a product of the LP1 working group, which also defines adaptation layer functionality, compressing header compression and fragmentation. So it uses a more aggressive compression technique, which might allow to compress an IPv6 UDP header into something like just 1 byte. the trick here is using some static context by using a priori knowledge of how the headers will look like for the packets that will be transmitted. Next, please. So, well, this is some background on how it works, but let's skip this for now. So yeah, the question would be, so the draft offers a discussion around 3 possible approaches for a dispatch type for SHIC. So I'll go directly to the third one, which I think is my favorite one, where, well, it would be based on using the RFC 8025 concept of pages to extend the SHIC dispatch type. So in order to keep overhead low, we might consider allocating a whole page for SHIC header compression, since anyway, pages are currently quite unused, other than page 0 and a little bit page 1. So it would mean a SHIC dispatch pattern of 4 ones and then some combination of 4 bits to be determined. This would allow a 1-byte SHIC dispatch pattern, and then, for example, there could be, should I say offline? Well, basically, that's the main idea. So it might be, in the best case, possible to have a dispatch and also the compressed header in 2 bytes. So, well, I guess that we may continue discussion on this on the mailing list. And, well, it will be great to hear your feedback and comments on this. So, well, I don't know if there's perhaps time for a really quick comment. Rahul? Lohan?
Okay, so I have a question about, so will the SHIC compression work on a single hop, or will you consider even the multiple, multiple hops as part of this route, as part of this work?
Yes, I understand that the idea would be to be able to use this in either single hop or multi-hop approaches, because this is only the header compression part.
I couldn't get it clearly. Sorry, Carlos. Maybe I'll take this up on the mailing list.
Okay.
It's in general, it's really nice to see SHIC getting used in 6LO context as well. Thank you for this. I think it's an interesting development as well.
Thank you.
Yeah. So I think also it's a good idea. I think a discussion will be very, very difficult with you because your voice is very cut, and so I will go to the mailing list. But I support this, and maybe we will need also header compress to keep IPv6 compressed as a 6LO, and to put SHIC for the upper layers.
Yeah, great idea. Also.
I cannot hear you.
Okay, I hope, well, I don't know if you can hear me. Okay. Yeah, so I don't know if anyone is correctly, is able to correctly hear my audio. So I guess that it is the time to finish the session. Thanks to everyone who has attended, and let's definitely continue discussing on the mailing list. Apologies for any issues with the audio. I have no clue why they have been happening. But yeah, let's continue discussion on the mailing list, and hope to see you soon in another meeting soon. Okay, thank you everyone.